Hi, welcome to Web Sign Wizard. Today I'm just doing a quick video to show you how to do number 5 on lab 7, which is, let me open my iPad. Assuming gravitational potential energy is transformed into translational kinetic energy only, show that the slope of v2 versus delta y should be twice the gravitational acceleration of the Earth, 2g. Alright, so what this question is saying is that on our graph, v2 versus delta y, which is linear, that the slope, which is, let me just write it, v2 over delta y, because if you remember, rise over run from algebra, is equivalent to 2g. That's what they want. That's what they're telling us. And they want us to do a derivation to show how we know that. To do that, we have to look at the problem. This is my rough sketch of the problem. So here we have our ball, the bricks, the ramp, the track, the photo gates, all of that stuff. So we have to look at the energy of this ball. Now when this says, I believe it says translational kinetic energy only. Yes. Translational kinetic energy only. That means there are two types of kinetic energy. There's the kinetic energy that we're familiar with, which is translational, and then there's rotational kinetic energy. This is saying just to worry about translational. Oh, did I say translational for this? Rotational kinetic energy. They're saying just worry about the translational, which is the one that we're familiar with. Ignore rotational energy. Even though this ball is rotating, just completely ignore that that's going on. And that will come into play later in the problem. We'll have like a correction factor. That's what that is. Where did I put my eraser? Do I have one? Oh, I do. Found it. So let me just get that out of the way. Alright, so how are we going to derive this? We have to look at the energy at the ball. So at the beginning, it's at rest, and it's high up, and all of its energy is gravitational potential. I'm not sure if you can read this. It might be a little too small, but you know what I'm doing. And then it has no kinetic energy because it's got no velocity there. Here, it is at height 0, so it's going to have no gravitational potential energy, and it's going to have velocity, and there isn't a spring or anything like that, so there's no spring potential. So it's all going to be kinetic here. This is an isolated system. We're not worrying about friction or anything like that. So now we know this, and we're trying to get v squared over delta y equals 2g. How are we going to do this? Well, we know that the total energy at the top is going to be the same as the total energy at the bottom. So at the beginning of the experiment, it's going to be the same as at the end of the experiment. So we know that UG has to equal K. So now we're just going to use our equations. So mg delta y is equivalent to 1/2 mv squared. Okay, well, we can take mass off of both sides, divide by mass here, divide by mass here, and we end up with g delta y is equivalent to 1/2 v squared. Alright, so now I'm just going to divide by delta y on both sides. Divide by delta y, divide by delta y, and I'm just going to move over here so I have a little more room. And now we have g equals v squared divided by 2 delta y. And you see I just turned that 1/2 into divide by 2 just because it makes it easier. So I'm going to multiply by 2 on both sides to get this out of the bottom. And then we have 2g is equivalent to v squared divided by delta y, which is what we were asked to find. So we did it. There we go. It's the slope of this graph. Alright. Hopefully that was helpful. If you need any more help, I won't be in the caf tomorrow morning. I have math league, but I might be around at like lunch or something. I'm not really sure, but if you just see me at some point during the day, then I could probably help. Anyways, hopefully that was helpful. Thank you for watching. Bye!